Hey everyone, my name is T-Jabs, and this is Replicube. It's a game I'm hoping to let's play. I think it's either going to be a really cool creative project, or one of the worst creative projects I have done in a long time, but I can't decide which it is, and I don't think I know until I start doing it. I say that like I haven't had 2 or 3 tech runs of this that have failed, but that's okay because like the game we're about to play, it does create this incredible element of optimizing a thing for the future. So initially I had run through the entirety of Replicube's tutorial to try and explain it, to explain what was going on, and I think that was outrageously boring, but I think it also hit at what kind of the thing I'd want to explain in an intro video is, because my hope is that this becomes something of a play along at home. So what this is this is a game where we are doing a coding thing. If you've ever played a Zachtronics game, it's hitting a little bit of the same vibe in that we are attempting to solve a problem. We're attempting to do a thing. In the case of Replicube, we are trying to replicate the thing up here, and this is where we are at currently. Where this is different from a Zachtronics game is that in Zachtronics games, there's this layer of fantasy that exists. So in Opus Magnum, you're an alchemist. In Exapunks, you're hacking your own body and local banks and what have you. In Replicube, you're making the cubes, and you're not doing it with funny machinery, you're doing it with actually Lua code. So it's a specialized version of Lua, which I have not used before playing this game, but basically for each little voxel here in this cube, it is running through some code and returning a value. In here, the simplest one, it's just saying return purple, which is also return 6. You can have it as a numerical thing. So if I say return 6, it's the same thing. Up here, we see that we have a big cube, and if we kind of mouse over it, we see that everything equals 7. So we can return 7, and what do you know? We match the cube. That's the very long and short of it. All of the tutorial functions in this game are kind of showing you different things about, what might be happening. So in the case of like simple quadrant, if we start a new version of this, hey, we have a code, and clearly we have this little box up here. And so we just need to find a, set of conditions, set of things that we can code in that will return this color 5. And if we start to examine the code, you can kind of see, well, here on the XY scale, if X is, greater than 0 really, well then there's a cube there, as long as Y is greater than. And we kind of have this thing here where if X and Y were to equal 0, it winds up here at the origin point. So if we go ahead and we were to say, well, what if instead we said Y was greater than 0? Okay, well, we kind of see that. And then if I said, and if X was greater than 0, well, hey, that starts to look right, except if we turn it sideways, we see that we also have the Z-axis to worry about. So I can, here in my little Lua window, go, and Z is also greater than 0. Okay, now we have the right shape. Now we just have to return the color, and the color is 5. I prefer to use the color numbers. It makes more sense to me. It doesn't have to make more sense to you. So that's like the gist of it, right? We're trying to find different variables and different things that make the code. But if you've played a Zachtronics game before, you might also be curious about that, yes, there is this scoring system. How big is your code? How many things does your code have to do to exist as a Word document and its cycles? How many things on average does your code have to do per little voxel in order to get the shape? And so you can kind of compare yourself on the leaderboard. Here at the very small end, there's going to be micro adjustments. Some coding wizard might be able to do something, but like we have a pretty straightforward, hey, if you're in this coordinate, give us the color, otherwise it's nothing. So what I'll do for this intro video is I'll go over here and you'll see that there's 8 million tabs of code. Don't worry about that. Please don't worry about that. Boy howdy. But I think this is one of the first puzzles where we can really get on this intro. So we have this little sushi roll. And, you know, we can see the cube is all filled in. So everything's going to return something. But we have different colors here. And if we see those go all the way in depth, so it's kind of like we have an outer box of green, and then an inner box of white, and then the center is red. So we kind of saw from the last one we showed off, that if we had if x is equal to 0, and I'm not going to go through like Lewis syntax on these, but I will try and describe what I'm doing. It's fairly simple coding language, but if I do if x is equal to 0 and y is equal to 0, then I don't want you have to say it. And then we have to end a condition. I like to write those and then write everything in the middle. But all we have to do here is return 7. Okay, and then we have the center is filled. So this code is technically running on every voxel. It's just that, you know, if it returns it, it won't have to go on. So if I were to say return 1, you can kind of see we can shape out the tunnel here a little bit, because we have, you know, we have this little thing where it's like these also would technically return 1, but they've already returned a value, so they don't run the remainder of the code. So if I said, let's say, you know, what's something we can say that's true about, you know, the inner or outer rim, because as long as we can isolate one of those, we should be able to get code that gets everything. And the thing that sticks out to me and that the tutorial will kind of hit you with is, A, it's symmetrical and it goes around the edges, which are 2 and -2 in both directions. And we have the mathematical operator for the absolute value. So if I were to say, if the absolute value of x equals 2, and we can actually, you know, quickly just, you know, show off what that's going to look like. Return 11, I think, is the code. See, we can see that it has a, you know, it's gotten us the edges. So if that's true, or because we want to do that vertically, y, the absolute value of y equals 2. Aha! Then we get those. Then for everything else, I can just return 1. And we have our sushi thing, and we can submit that. Now, I've already done this puzzle a few times, as you might be able to observe. And this, you'll see down here, we have code size +3, cycles per voxel +0.4. So, I mean, I could submit it, it doesn't really matter. We can see that it's smaller than a lot of people have done. Or my best effort is smaller than a lot of people have done. It's actually about where people normally are. And my fastest is, it's kind of on like the plurality, I guess, of where people are. This game isn't super big, I don't think. Well, I mean, 3,000 people, that's pretty fucking respectable. And that's not even the end of it. This is page 61 of 93. Yeah. That's a lot of people. Damn, did I win? I respect the hell out of that. That's somebody who did it on purpose, right? They did 9,000, on average, about 10,000 instructions per cube. Damn, that's gotta be on purpose. But this is where I got into it, is so you can start to optimize for those things. So my first effort on this was, and I don't know why this was where I went for and what I hoped for, but my initial goal had been to create basically a distance function to create layers of cube. And then like, well, if the layer is 0, return this. If the layer's 1, return this. Otherwise, return this. And that does it in about 14 cycles. And so I think I did it, you know, I did it one of these ways as like, hey, I'm gonna do this for a previous version of this video that very much failed. And so I made like a bigger code that was a little bit faster. And the thing that was sad is, yeah, this was what I did first. This is the saddest story ever told. But it's also kind of what makes these games fun. So I said, I just went through and demonstrated, and I did kind of the same thing. I built out the outer, and then the middle, and then the inner, the middle, and then the outer was just everything else. And that did faster, and I was like, yeah, that's way faster. And then I said, well, we want to try and get the cycles down. So there's more cubes on the outside. So I bet if I run that code first, it'll go way faster. Which created this, which is basically the same thing in reverse, and it super didn't. And I'm not 100% sure why that is. It's some kind of, it's faster than like my very first solution, but it's not faster than going in to out. And then a lot of that video became unusable because I lost my mind attempting to, in different ways, abstract out this idea. This is the fastest code I got to, which was, hey, if it's not the outer shell, well, then if it's 0, do one thing. If it's not the middle, then do another thing. Otherwise, return the outer shell. Is the fastest I've gotten it to, and that's where I got under 10. But I have just been trying to do... I made an array. I wanted to see if an array was faster. The array is most definitely not faster. It has to do 20 cycles per. It's svelte comparatively. We have an array of the colors, and then based on its distance, you basically use that as an index for the array, and it's a total travesty. But I think this gets into the idea of what makes Replicube interesting, is that there's 100 million ways that you can express this code, and different ways you can kind of logic it out, and even different things you can pursue. Maybe it makes sense to, go for one thing over the other. Maybe you want really small svelte code. Maybe you want code that's really, fancy looking. Maybe it's slower, but it's like really just a few lines. Maybe you want some behemoth of code, but it does everything really, really quickly. And so what I'd like to do is there's, these intro things and these tutorials. I don't think we want to spend a tremendous amount of time on these. Most of these are trying to get you to look at a concept. Like this one's trying to tell you what modulo is. And modulo is the idea in math of if you divide something, what's the remainder? So here, if I wanted to recreate this shape, you'd probably start with something like x modulo 2, and we see that we're kind of there. And then it's oh, but it's offset a little bit. So it's it's almost the exact opposite thing. So you could do when x modulo 2 doesn't equal 0, doesn't equal 1, it gives you kind of the same thing. That's what gives you the match. But I don't think it's very, very interesting to just go through and explain mathematical concepts. Both because if you know them, then I'm just being redundant. And if you don't know them, it probably feels better to go ahead and just play around with the code yourself and get a feel for it. So my eventual goal is not to explain rote mathematical concepts to you and insult anyone's knowledge. I think it'd be fun, though, to go through. I basically did 4 of the game starting to really get into it. And what I'd like to do is kind of start over here and get into these first ones where we can kind of clearly see how this shape is getting more complicated. There's more layers of where things exist and conditionals and all this that I'd really like to start playing with and do 1 or 2 of these an episode, and then dive into ways we might be able to optimize it, but then turn it back out to, the Crittertime forums. And if this shows up, hey, if you're watching this on YouTube or this gets shown off somewhere else, absolutely feel free to sound off on what you did in the code. I'm more than happy for people to clown on me in doing these kinds of things. Maybe we'll make some fun stuff along the way. This is my upsetting piece of code. Don't worry, we'll get into how upsetting this was to make as we kind of do that episode. And my hope is that it will create some fun little moments for all of us if we kind of poke and prod at this game a little bit. So I'll leave it there, and then we'll see about coming back and solving and really getting into some cube dispensing. So hopefully you'll stick around and join me on this journey. And until then, y'all have a good one.